Hello everyone, this is Dr. R. Prabhakaran, working as Assistant Professor in the Department of Mathematics at St. Joseph Institute of Technology, Chennai. So today's session is going to be on Z-test. Before entering that, we'll see the some of the basic things, and then there are three major parts under Z-test. We'll see one by one. So we'll see the fundamentals of statistics before entering that. So if you go for analyzing any kind of data, means first we have to, instead of analyzing the whole data, we have to collect the samples, right? By the samples only we can go for the conclusions whether it's fit to the population or not. If 100% works means we can accept, otherwise we will not work. That's how. So we'll see the some of the notations which is helpful for to understand the things. If you consider any populations, the mean value, the average, is denoted as mu. This is mean of population, and standard deviation notation is denoted as sigma. If we consider the sample, the subset, the notation is mean of the sample is x bar, and the standard deviation is small s. These are all the four major notations we are going to use throughout this session. The thing is, if we are taking any samples, we are going to check whether the samples means equal to the mean of the population or not. The thing, in order to compare the sample mean with population mean, is there is a acceptance level of significance, right? If it satisfies means we can say that the given sample comes from the given population. So otherwise it won't, right? So this is the one case. We are going to take the only one sample, and we are going to check whether that comes from the population or not. There is another case, we are going to take the two samples, whether the two sample means are equal or not. This is the other case. And then the third case is we can compare the proportion of the samples with the population proportion. Similarly, we can take the proportion of the two samples and the comparing with population proportions. These are all the three major parts. So before, just try to remember, we are going to purely apply Z-test, and Z is only applicable for the large sample. Large sample is nothing but sample size should be, the number of terms in the samples must be strictly greater than 30. This is what the large sample, so that we can apply Z-test. As I said, there are three major parts. One is comparing sample with population, and then comparing two sample means. Try to remember, we are going to comparing the means of two samples, and sample means with population mean, and two sample means, and the third one is, as I said, proportions. In proportions, you can compare the single sample with population, and then next part is two sample proportions. So the thing is, next, before entering into the testing of hypothesis, there are only 4 steps. Try to remember this. First step is creating the hypothesis. Second step is applying the test value, test statistic. The third one is table value, and the fourth one is conclusion. So in the hypothesis, there are two parts. One is null hypothesis denoted as H0, H1. If you are comparing the sample mean with population mean means, we can take in the positive sense. There is no significant difference between sample mean and population mean. Other cases, the given samples comes from the given population. And alternative hypothesis, it's opposite. There is alternative for H1. That means there is a significant difference between sample mean with population mean. If you are comparing only a sample with population. If you are comparing the two sample means H0 is going to be null hypothesis mean. We are comparing two samples, right? For two samples, the two sample means are equal means that's going to be H0, null hypothesis. Null means there is no significant difference. H1 means that is alternative for that. Maybe one is greater than the another, one is lesser than the another, or the other cases both are not equal. So this is, as I have said, three cases for alternative, right? One is greater than the another, one is lesser than the another, and both are not equal. If not equal means, that is what. If it is not equal means whether it is going to be lesser or greater. If you are specifying in general, not equal means, we can say it as two-tailed test. There is going to be lies on the two sides. If one is greater than the another means it's going to lies on purely one side. That is, we can call it as one-tailed test. This is what the main difference between one-tail and two-tail. We are assuming two sample means are not equal means, that is two-tailed test. In general, if you are taking in general, for specific case one is greater than the another means, that's going to be one-tailed test. This will be helpful for finding out the table value of statistics. So when you are entering into the problem, you will get the better understanding of it. This is just an introduction. This is what hypothesis. Now I hope you can understand the key idea of what is a null hypothesis alternative. This is the first step. And z-test statistic test value. So it will vary, depends upon the problem, whether we are it depends upon we are comparing the sample with one sample with the population, or two samples means, or proportions. There are three parts we are going to see one by one. And the third step is table value. So in the question, if they have not mentioned any level of significance means, by the default we can take 5%. If they have mentioned 1% means we have to go with 1%. If they have not mentioned any percentage means, we can, by the default we can go with 5%. Just keep it in your mind. So here it comes one tail or two tails. If alternative hypothesis we are checking in general means, 5% is if two sample means are we have fixed as equal and not equal means. Not equal means it may be lesser or greater, right? There are two possibilities. That is what two tail. So two tail means 5% by 2, that is 0.05 by 2, 0.025. We have to see it in 0.025 instead of 5%. If it is 1% means, that is 0.01 by 2, that is 0.005. This is what two tail. Suppose H1 is, if we are fixing one sample mean is greater than the another, or mu1 is lesser than the mu2 means, this will comes under one tail tails. For that case, we can keep the level of significance as it is. 5% means 5%, 1% means 1%, while we are seeing in the table value. This is how we can see that in the table. The fourth one is conclusion. In the conclusion, we have to compare the z test value with table value. If table value is greater than the test value means, accept the H0. H0 we know that there is no significant difference between sample mean with population mean, or the two sample means are equal. Other cases, suppose z test value is greater than the z table value means, accept H1. So listen here. Now when you go for the table value, for z test also we have to make use of student t-test. This is an extension of t-test, so that until 30 it's a small sample. If it is greater than 30 means we have to go with large sample. So look at here, we have to go with this. And as I said, if it is a two tail means 5%, if it is two tail means 5% have to be considered as a 5% by 2, that is 0.025. This is 5% in two tail. Likewise, in the two tail test, 1% is nothing but 0.05. These two things are 0.005. Sorry, this is two tail, but the percentage is 1%. This is 1%. This is 5% in the two tail. Suppose it is one tail means we can take as it is. 1% is a 1%, 5% as a 5%. So 5% means this is what. I'm not going to circle this. You can keep as it is. This is 1% value. If it is a one tail, if you are comparing one is greater than the another, one is lesser than the another, means that is nothing but one tail test. That's all. Now we'll enter into the problem. This is the first problem. Before entering that, we'll see the formulas. As I said, we are going to check the significant difference between sample mean with population mean. So sample, I'll recollect the notations again. That is, x bar is mean of sample, mu is mean of population. So now it is already there. Mu is the mean of population, sigma is the standard deviation of population, x bar is the mean of sample, and as small s is the standard deviation of the sample, in which x bar is, we are comparing the mean of sample with mean of population, x bar minus mu. If they have given standard deviation of the population means, we can make use of this formula. The next thing is, we are going to compare the two sample means. For that, formula is, I'll give here itself so that you can get the better understanding what is it, how you can perceive the formulas in different way. That is, if you are comparing two sample means x1 bar minus x2 bar divided by s1 square by n1 plus s2 square by n2. This is what the formula for comparing the two sample means. Now we'll enter into the problem without further delay. First, read the question, try to understand the questions. So if you read the questions twice at least, then only you can get the better understanding of it. The first line itself, you can guess which test we need to apply. As sample of 900 items, as mean 3.4 centimeter, and the standard deviation is 2.61 centimeter. And can the sample be regarded as a drawn from the population with mean 3.25 centimeters at 5% level of significance? So first write the what are the things they have given. First things, sample size is 900, and then mean of the sample is denoted as x bar. See, it is only one sample, 3.4, and the standard deviation is small s, 2.61. And we are going to check this sample comes from the population. The population as a mean is 3.25. So the population mean is 3.25, and the level of significance they have given 5%. This is all the things they have given. So the first step is we have to create the hypothesis. As I said earlier, the question itself we can formulate the hypothesis. We are going to check the sample comes from drawn from the population, so that we can take H naught as a the sample drawn from the population. Alternative is this, just opposite sense. The sample does not drawn from the population. The sample does not drawn from the population. This is what null and alternative hypothesis. If you want to write it in terms of notation, means what they have asked, whether the mean population is, the mean of the population is 3.25 equal. If it is not equal, means 3.25. This is the notation. You can write it in either one of the cases, not necessarily to write both notation and the wordings. If you are comfortable with wordings, means write it in the wordings forms. Otherwise, you can simply represent it in the notation form. Next, we will move for the Z test. The formula is x bar minus mu s by root n. X bar value is 3.4 minus mu value is 3.25 and standard deviation of the sample is 2.61 and sample size is 900. Just you can make use of the calculator and try to find the answer. The answer is comes, just use your calculator. The answer is 1.72. First step is over, second step is over. The third table value is Z alpha, that is 5%. Before that, we have to check whether it is a one tail or two tail. Look at the alternative hypothesis. We are going to check whether it comes from the given population or not. The sample drawn from the given population. We are not going to check the sample mean is greater than the population mean, or the sample mean is lesser than the population mean. Just simply whether it is drawn from the population or not. So obviously it is two tail test. Two tail means we have to take the half of the value, right? 0.05. The half of the value is 0.025. When you go for the table, that is 0.025. Since it's a two tail, the table value is 1.960. 1.96. So that conclusion. Test value is 1.72. Table value is 1.96. By comparing, which is greater? The greater value is table value, obviously. So Z is lesser than the Z tabulated value. So that since the tabular value is greater, we can accept the H0 null hypothesis. That means the conclusion is the given sample is drawn from the, which supports the given sample is drawn from the given population at 5% level of significance. So we'll go for the next problem. So quickly recall the things. A sample of 400 students have mean height 171.38 centimeter. Can it be reasonably regarded samples from the large population with mean height 171.17 and standard deviation is 3.30? Okay, now the screen is visible. It is not changing properly. Okay. Now. Okay. The same way, we can write the H0 as null hypothesis in this. Before that, first understand the question. The sample size is N1 is 400 and mean is 171.38, and they have not given standard deviation in the sample. Instead, they have given, can it be reasonably regarded as a sample from the large population? Population mean is, mu is 171.17 with the standard deviation, sigma value they have given, that is 3.30. So the same problem, in this they have given the standard deviation of population. H0 is, there is no significant difference between the sample mean and population mean. You can write it in that way. Otherwise, the question itself we can frame, the given sample is drawn from the given population. H1 is, the given samples does not come from the given population with respect to the mean and standard deviation. So you can write the H0 and H1. Z test formula is, it will vary little bit. X bar, we are comparing mean of sample with mean of population, sigma by root n. This is X bar value is 400 minus mu value is, sorry, sample size is 400, 171.38 minus 171.17 by sigma value is 3.30 by root of n value is root of 400. So just find out the value. That comes nearly 1.27. Now we can go for, since H0 is, we are comparing in general, we are not comparing one is greater than the another or one is lesser than another. It's a two-tail test. So two-tail means when you go for the table value is at 0.05, but we are going to see it in the 0.025. Since it's a two-tail test, the answer is, already we know that, 1.96. By comparing test value and the table value, the conclusion is accept H0. So the the next example is a normal population as a mean height 6.48, that is mu value is 6.48 population mean, and they've given standard deviation is 1.5 and the sample size is 400 and its mean is 6.75. So is the difference significant? So that we can write H0 as a, there is no significant difference between sample mean and population mean. In H1 there is a significant difference. It may be lesser or greater, so that there is a significant difference between sample mean and population mean. So obviously it's a two-tail test. So we are going to apply the Z test, that is x bar minus mu by, in this problem they are given the standard deviation of population sigma by root n. X bar value is 6.75, right? 6.75. Mean population is 6.48 and divided by sigma, that is standard deviation of population 1.5 by square root of sample size is 400. So just use your calculator. The answer is 3.6. Now since it's a two-tail and they have not mentioned level of significance, we can take 5%, but the 5 in the 5% we have to take 5 by 2, 0.025, that is 1.96. repeatedly we are getting the same value only. So the table value is Z alpha, that is 0.05, but we have must seen in the 0.025 half of the value, since it's a two-tail, that is 1.96. By comparing these two things, what is the conclusion? In this problem, Z test value is greater than the Z table value. So the conclusion is accept H1 or reject H0. This is the answer, solution for this problem. So what does it mean? That means the given population is, the given sample is, does not come from, it's not supposed for the population with respect to the mean value. So there is a much difference. That's what significant difference between sample mean and population mean with respect to the average values of both. So next we'll move on to the next type, that is comparing two sample means. That is sample mean of first sample and also second sample. That is x1 stands for first sample, second sample, s1 square by n1 standard deviation of first sample, standard deviation of second sample, and n1 represent for sample size 1, sample size 2 for, that is n2. If both samples are equal, or they have, instead of giving the standard deviation of sample 1 and sample 2, if they are giving standard deviation of population means, the formula will change, right? Suppose if you are applying the same thing, x1 bar minus x2 bar, that is sigma sigma square of by n1 sigma 2 square by n2 means the sigma square is common, you can take it out, we'll obtain this formula. Both are same. This is how you can understand. So instead for further delay, we can directly move to the problem. Just statistics is very easiest things if you understand the question thoroughly. Just try to understand the question. A random sample of 100 bulbs from a company P shows a mean life 1300 and standard deviation of 82 hours. So there is a company called P and another random sample of 100 bulbs from a company Q. There are two companies P and Q. They have given the 100 bulbs, and known as 100, and the Q another random sample of 100, both are same. And then mean x1 bar is 1300 and Q showed the mean life, that is average, right? X2 bar is 1248 and the standard deviation of the first sample is 82, second sample is here 93. So this is what the data they have given in the questions. Now we can going to compare. What first read the question. Are the bulbs of company P superior to bulbs company Q? So superior. So far they have asked in general, but in this specific question they are asking us to find P is superior to the company Q. So that first step as usual H0 and H1. H0 is null hypothesis, right? The null hypothesis means both companies P and Qs are same. There is no significant difference. That's how we can write. Other cases, P is not superior. Both are equal. This is how we can write by your own wordings. If you want to write it in terms of notation, means both sample means are equal. That is mu1, mu2, mu1 is greater than mu2. So you might have, you can get the question in your mind that why we are denoting mu1 and mu2 instead of x1 bar. We are comparing the sample first two sample means, right? The thing is, try to understand, if this is a sample comes from the population, this is another sample comes from the another population, means both are different populations. This is how the meaning. Whereas mu is a mean of the first population, mu2 is a second population mean. What does it represent? It represents two samples are different means, so that it is obvious case that both the two samples comes from the different population with a different mean level. Suppose these two means are same means, we can conclude that both samples do not come from the different population, but it is comes from the same population. That is the reason we are just writing in terms of mu1. That is, now we can understand that H0 is not the two tail, it is simply one tail test. So now we can go for applying Z test, that is x1 bar minus x2 bar square root of s1 square by n1 s2 square by n2. x1 bar value is 1300, 1248 by s1 square value is 82 square plus by n1 100, 93 square by 100 square root value. The final answer is, just use your calculator, the answer is 4.19. So two steps are over. Next we can go for finding out the table value. Table value is, they have not mentioned LOS, that is level of significance, but 5%. So 5%, but we are comparing one is greater than the another, that is one is superior to the another. So P company is whether we are checking P is superior to Q or not. That's what our ultimate aim. So it is a one tail. In the table value, as usual, the student says it's a large sample, and then since it's a one tail, It's lies only one side. We are checking only in the right hand side, so that 5% we can take as it is 5%, 0.05. The value is 1.645. The 0.05 table value is 1.645. So now by comparing these two things, the conclusion, z test value is greater than the z table value. So we have to accept h1. If you want to write in another way, reject h0. That means P is not superior to company Q. That's all. Now, so you can do it by your own. This is a direct question. We are going to compare these two samples comes from the is there any significant difference between the two sample means with the 5% level of significance. First sample size is n1, this is n2 mean value, so that x1 bar, x2 bar, this is s1, s2. These are all the things they have given, so that we can write h0 as a there is no significant difference between two sample means. H1, there is a significant difference between two samples. So z test is x1 bar minus x2 bar, s1 square by n1, s2 square by n2. So x1 bar value is 72 minus 74, and s1 square is 8 square by 32 plus 6 square by 36. By solving, just use this, the answer is minus 1.5. So one thing you have to remember, when you go for the conclusion, we have to compare with absolute value. This will become 1.55. Now we can go for the table value 0.5. Since in this problem we are just in general we are checking whether the two sample means are significantly different or not, so that it's a two tail. So two tail means you have to look it half of the value level of significance, that is 5%. Instead of 5%, you have to take half of the value 0.025. The answer is 1.96. By comparing these two things, test value and table value is greater. So by conclusion, z test value is lesser than the z table value, so that we can accept h0. That's all. So quickly we'll see. So you can take it this as a homework problem, you can work it out. I'll give the answer. This is x1 bar, x2 bar, and sorry, this is x1 bar, x2 bar, this is s1, s2, and sample sizes for both samples as 400. N1 is 400, N2 is 400. Read the question, test whether the average sale is same in the two states. So this is also in general question. This is, we are going to compare the two average sales same or not, equal or not. That means it's a two tail test. I will give all the clues, but you have to work it out and try to find the answer for this. I'll give the answer also. The z test value is 8.8. Just check. And since this is a, I'll show the how to find see the table value. 1%, right? 1% level of significance. Since it's a two tail test, instead of seeing in the 0.01, we have to take we have to see it in the half of the value. That is 0.01 by 2 is 0.005. So this is what the 1% in a two tail. If it is a one tail means we can check it in the usual things, that is 0.01. so table value is 2.576. just compare and write your own conclusion. Next we'll move to this problem. A simple sample of height of thing screen is not visible. Okay. A simple sample of height of 6,400 Englishman has mean height of 117 inches and standard deviation of 6.4 inches. So this is Englishman, and a simple sample of height of 6,400 Englishmen has a mean height of 170 inches and standard deviation of 6.4 inches, while a simple sample of heights of 1,600 Australians has a mean of 172 inches and standard deviation is of 6.3 inches. The question is, do the data indicate that Australians are on the average taller than the Englishman? So we are going to compare Englishmen with Australians. The average height is one is taller than the another. So by reading out, they have given the two samples, one is Englishmen, another one is Australians, and they have given their average height and standard deviation, and moreover they ask us to compare Australians are taller than the Englishmen. So this is what, so that H naught is, you can take in the positive sense, that is null hypothesis. Both average heights of English and Australians are same. That's how we can fix the H naught. But H1 is alternative hypothesis, right? The Australians are on the average taller than the Englishmen. This is how we can fix the hypothesis. H naught always in the positive sense. There is no significant difference. Both are same. That's how we can fix. But H1 is the specific case. Australians are taller than the Australians. Average height is taller than the average height of Englishmen. This is how we can write it in terms of wording. H naught is, there is no significant difference between mean height of Australians and Englishmen. So now we can go for applying Z test. The formula is x1 bar minus x2 bar divided by s1 square by n1 s2 square by n2. So first x1 bar, the average height of, if you consider a first sample as a Englishman means the average is 170, whereas x2 is 172, and s1 square, standard deviation of the first sample is 6.4 by the respective sample size is 6,400 plus 6.3 square by the sample size is, well, sample of inches standard deviation 1,600. This is the standard deviation sample size. So by applying, we can find the value. Just use your calculator. It comes under minus 11.32. So when you go for the conclusion, we have to compare with the table value. Since it's a one tail test, you can take the, by the default 5%. The 5%, so one tail you can keep as it is 0.05, 1.645. So the conclusion is table value is 1.645. by comparing table value is lesser, that test value is greater than the table value, so that we can accept H1. That's all. So we have seen Z test with a simple mean, and by comparing simple mean with single sample mean with population mean, and also comparing two sample means in the sections. Then I will continue further, that is we'll see proportion in the later. Thank you.